Hi everyone, welcome to Digital Electronics and Computer Organization subject. In this session, we are going to see some brief overview about the very familiar subject of digital electronics and computer organization. So this subject is common for both computer science and engineering students, IT students, even uh, electronics and communication engineering students also. Let's see some brief overview of the subject. First question is why do we study computer organization? The computer organization is the subject concerned with the behavior and the structure of digital computers. This subject aims to provide an overview of the basic computer hardware structure, including the peripheral devices as well as the overall design. Why computer organization is very much need for the budding engineers who are doing computer science and engineering. The subject explores how machines are designed, built, and operates. Knowing exactly what is inside and how it works will help you design, develop, implement higher level applications better, faster, cheaper, and more efficient. All. What is the benefit? Why we need to learn the computer organization subject? After learning the computer organization subject, what are the benefits we will get? It makes the programmer possible to write computer programs that are faster, smaller, less error prone. Also allows the programmer to appreciate the relative cost of operations and the effect of programming sizes. Also helps the programmers to debugging the process very easily. Other benefits like design, the programmer can able to design better programs, including system software such as compilers, operating system, device drivers, etc. Without knowing the fundamental concepts of computer organization, it is very tough to design this kind of low-level softwares like compiler, operating system, device drivers. Apart from that, learning computer system helps the programmer to optimize the behavior of the program. Either they can increase the speed of the program by reducing the size of the program. Also, one can able to easily evaluate the computer system performance by knowing the understanding of computer organization subject. Also can understand, programmer can understand the time complexity, space complexity, and the space trade-offs. What are the various applications of computer organization where we are going to use this, use the knowledge of computer organization? Once the knowledge obtained from computer organization subject, it can be used to measure the performance analysis of practical software. Also, parallel software and its execution. It is used in embedded systems, mobile computing. Also, it is used to measure the performance of game programming. It's also used to measure high performance databases. One can understand about accelerator, GPU computing, also related topics. Then he can understand about modern compilers and code optimization. So what is the objective of this computer organization subject? Principles and the implementation of computer arithmetic. This is a major objective of computer organization subject. What is the second objective? The student can able to understand the basics of computer organization under their logic design. The third important objective is one can understand the operation of the processor, all the elements available in the processors, including arithmetical logical unit, registers, how the instruction cycle and how the data is communicated between different components through different types of buses. Next, the important objective is one can understand the fundamentals of control signals generation, where the control signals are generated by using the control signals, how the instruction execution is controlled. Finally, the main objective is what is memory system? what are the different categories of memories were available, and what are the different IO devices were available, how these IO devices are communicating with the memory system. So these five important objectives are very much required for the, this is a core objective of computer organization. What is the course outcome? The student can able to understand, or the student can able to understand different number systems like binary addition, subtraction, standards, and the various floating point operations and the micro operations. The another important outcome, the student can able to design the logical circuits like various encoders, decoders, what is the use of multiplexers, the design of multiplexers also. The third important outcome, the student can able to understand the organization of various components available in the computer system, also their logical circuits. Once the at the end of the learning, the student can also able to describe the design of control units. He can able to exemplify in a better way the IO and the memory organizations are available in the computer system. This is a major outcome once the student can get after learning this course. Let's see the brief overview of the digital electronics and the computer organization subject. The first unit contained majority the number systems, binary numbers, octal numbers, hexadecimal numbers, complements, how the ones complement and the two's complement of the numbers, how additions, subtraction, what are the different algorithms used for addition and subtraction, various logic gates, and the map simplification. So at the end of this first unit, the student can able to recall the various data representations he learned, and he can able to summarize various arithmetic algorithms for fixed point representation. Also, they can able to apply various algorithms for floating point arithmetic. The second unit little bit logical diagrams, and this it called digital electronics. So through this second unit, one can able to easily know what is the computatorial circuits, what is the design of flip-flops, how the decoders, encoders are designed, and what are the designs of multiplexers. So the second unit, the student can able to understand the various combinatorial circuits, can able to summarize various encoders and decoders and multiplexers, can able to apply logical circuits to solve the problems. The third unit fully completely contain the basic computer organizations under their design. It normally contain micro operations, what are the instructions codes were available, how the instruction cycle is executed, what is memory reference, how the input output instructions, what are the different format of the instructions, various addressing modes, and how the data transfer between various components, how the program is controlled by control units. So the third unit, the student can able to understand various micro level operations, and he can identify the different instruction formats. He can able to know how the data transfers between various components. The fourth unit contains the control units, how the control signals are generated, what are the different types of control uh, unit were available. Normally, we have a microprogrammed control, hardwired control, what is actually the control memory, how the address sequencing. Let's see some examples for microprograms. Then, how what is the design of control units? After the fourth unit, the student can able to describe knowledge on microprogramming, understand various principles of IO devices are accessed, understand various data transfer between the components. The fifth unit, it is talking about the memory and the IO organization. Two major categories. First one is memory organization. What is memory hierarchy? What are the various different types of memories available? What is actually main memory, auxiliary memory, associative memory, cache memory, virtual memory? And the second part is the input output organization, where what are the input output peripherals that's available, how they are connected, and what is actually the asynchronous data transfer, what are the different modes of transfer, what is the use of interrupts to control IO operations, and what is memory, direct memory access. So at the end of the fifth unit, the student will be able to understand what is actually the memory system, how it is designed, we can able to demonstrate the concept of hierarchical memory organization, and we can able to explain the concept of memory well. Also, we can able to understand what is actually the dynamic memory access. So here we are going to conclude, and these are all the textbooks available for this syllabus and the reference books available for this subject. And these are all the resources you can learn online. So by this, we are concluding this session. Thank you all.